Sir Isaac Newton's laws of motion describe the relationship between the motion of an object and the forces acting upon it. These laws are fundamental to classical mechanics and apply to everything from everyday objects to celestial bodies. The first law, or law of inertia, states that an object at rest remains at rest, and an object in motion continues in motion with the same speed and in the same direction unless acted upon by an external force. This law states that objects resist changes in their state of motion, a property called inertia. If no external force, like friction or air resistance, acts on an object, it will continue moving indefinitely or remain stationary. For example, a book on a table stays at rest until you push it. A moving car continues to move forward unless brakes are applied. Passengers in a car lurch forward when the brakes are suddenly applied because their bodies want to keep moving due to inertia. The second law, or law of acceleration, states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, this is expressed as F-ma, where F is force in newtons, m is mass in kilograms, and A is acceleration in meters per second squared. This law explains how force influences an object's motion. A greater force produces greater acceleration, but if the mass is larger, acceleration decreases. For instance, pushing an empty cart versus a loaded cart shows that if you push both with the same force, the empty cart accelerates more because it has less mass. Kicking a football with a stronger kick results in greater acceleration. A truck requires more force to accelerate than a small car because of its higher mass. The third law, or action-reaction law, states that for every action, there is an equal and opposite reaction. Whenever one object applies a force on another, the second object applies an equal and opposite force back. These forces act on different objects and do not cancel each other. For example, when you jump off a boat, pushing against the boat causes it to move backward. In a rocket launching into space, the rocket pushes exhaust gases downward, and in response, the gases push the rocket upward. When walking, your feet push backward on the ground, and the ground pushes you forward. In conclusion, Newton's laws of motion explain the movement of objects in everyday life and advanced physics. The first law describes inertia, the second law relates force, mass, and acceleration, and the third law explains action-reaction forces. For notes, see the description.